Hey guys, in this video I would like to show you my latest project, the Tiny Tetris. In the last video, I showed you my Tetris gaming device. There are a couple cool features on this device, including the accelerometer for game control, vibration motor for feedback, and piezo speaker for you to listen to the Tetris theme while you're playing. But there are a couple things I don't like about it. First, it's a little too big to be carried around easily. You certainly can't put it in your pocket. And second is that you need a special charger, special LiPo charger to charge it, because it uses a 7.4 volts LiPo battery, and you can't use the USB charger to charge it. So I've decided to build the second version of the Tetris gaming device, which I now call the Tiny Tetris. And as you can see, there are actually built 3 different colors of it. So if we just take a look at one of them, on the front we have the same 8x16 LED matrix, but this time instead of the RGB LED matrix, it's a monochrome, it's a single color LED. And on the bottom we have the navigation switch, which is just left, right, up, down, and select. On top we have a push button on-off switch. So if you press it once, it turns on. Now the power indicator turns on as well. And press it again, it turns off. So let me turn it on, back on again. On the left side we have the 2 general purpose buttons, which is now configured to adjust the brightness of the LED matrix. So if I keep holding the up button, definitely got brighter. Then if I keep holding down, it's got dimmer. So on this side, on the right side, we have another button. It's the reset button. It's directly connected to the reset pin on the microcontroller. On the bottom, we have a micro USB port, which is for both charging and programming the microcontroller with the Arduino IDE. And here we have the 6-pin ICSP header, which can be used with the USB Tiny or other AVR programmers. So let me show you what you can do on the Tiny Tetris. Now there are a couple things you can do. Not only Tetris, but if I press the right button, you can switch between different programs. This is Tetris, this is Snake, and third one is a draw program, which you can draw clear dots on this canvas. You can draw whatever you want. So let's start with the Tetris, and it's very simple. It's basically the same as the last one. So the old Tetris. So here we go. Alright, so let me just quickly drop all these pieces. So that's, and now we can, if say we want to switch to the Snake program, we can press down the select button and press one of these 2. That's forward, that's forward, that's backward. So if we want to switch to Snake, we'll press that. So hold that down, press that button. Now we're in Snake. And as the snake eat more items, it would speed up. So here we go. Still a couple more. And that's one way. Whoa, accidentally. Okay, that's one way to cure yourself. I pressed left there and it just died there. So that's the Snake program. And if I switch to the third one, this is the draw program. So you can draw whatever you want. Use left, right, up, down to move the cursor, and the select button to either draw or clear a dot. So I can draw like that. that's a heart. And if I now press down the select button, hold it for 3 seconds, it will clear the display. And now, of course, you can also do it this way. Let me just draw something really quick. Oops. There we go. Hello. And same thing, you can press and hold the select button for 3 seconds and it will clear the display. So that's the 3 things you can do on this device right now. And I will definitely try to write more programs that you can do on with this device, but since the display is limited to this 8x16 LED matrix, there's kind of a restriction as to what kind of game you can play on this. Okay, so let me turn it off again. So now I'll talk about the physical construction of this device. So you can see this enclosure, while being different from the old Tetris. The old Tetris has a 3D printed enclosure. It's 3D printed on a Stratasys 3D printer. It's a 2-piece design, top and bottom, and there are 4 screws on the back holding the 2 pieces together. While on the new tiny Tetris, the enclosure is laser cut, and it's a 6-piece design, top, bottom, and the 4 sides. And on the 4 sides, there are these tabs that plug into the top and bottom pieces for structure and rigidity. And also there are 4 screws on both the top and bottom that holds everything together tightly. So that's the tiny Tetris. So here's the tiny Tetris taken apart. I unscrewed all the 8 screws, and here's the circuit board with the battery on the back. This is like 3mm thick battery. I chose this over the more popular 6mm battery to reduce the thickness of the device. And you can see these buttons that we talked about. These are just mounted on the edge of the PCB. So you can press it like that, and oh, that powers on. So on these acrylic pieces, it's just a cutout like that, and it has a limited. It can bend a little bit, and so it will touch the button and trigger the button. And that's the joystick, the micro USB connector, and the 6-pin header. And I've removed the LED matrix. You'll see the rest of the components on the circuit board. So here's the microcontroller. It's the ATmega 32U4 microcontroller, same as the Arduino Leonardo. And these are some passives. There's the soft latch push button power switch is located here. It uses I think it's a NAND gate, double NAND gate to double inverter with Schmidt trigger as the latching circuit. And here we have a boost converter that boosts the battery voltage from the LiPo battery to a standard 5-volt voltage to run both microcontroller and the LED driver. So the LED display driver consists from Holtec. It's the same as the one that Adafruit sells with their LED backpack. It's pretty convenient. It handles both the LED and these buttons. So you don't really need any other I/Os from your microcontroller. Now that's And also here is the charging IC, which is a very popular microchip 73831 charger IC. And that's pretty much it. And also another thing to talk about is these headers that I've soldered on. Initially, in the very first design, I have these LED matrix soldered directly to the circuit board, but I realized it's going to be a nightmare for debugging, hardware debugging, if there's anything soldered incorrectly, or if I want to cut a trace or replace a component, it will be impossible, nearly impossible. So I've decided to add these headers, and then plug in the LED on these headers. It won't increase the height, the thickness of the device by too much. As you can see, there's only a tiny gap in there, but it makes everything more convenient. So that's the tiny Tetris, and also have these and have it in different colors. For example, the red one, using the red LED matrix, same construction, and also a green one. Now this is the green LED matrix. Alright, that's it for today. Thanks for watching.